You can mathematically break apart a sphere and rearrange the pieces to make two identical copies of the original. But how is that possible? This is the Banach-Tarski Paradox. To understand how it works, we need to start at the very beginning, with infinity. Infinity isn't a number, but rather a description for all numbers. Let's look at two infinite sets, the set of all natural numbers and the set of all even numbers. Which one is bigger? It seems that the set of natural numbers is twice as big as the other because it contains both even and odd numbers. But as it turns out, that doesn't matter. We can match up each even number to a natural number, and since both sets are infinite, they would never run out of numbers. These sets are exactly the same size. This leads us to believe that infinity divided in half is still infinity. So why are we even talking about infinity? Well, the Banach-Tarski Paradox only applies to an imaginary sphere, which contains an infinite number of points. Now, instead of using numbers, we are going to use only 4 letters, D, L, R, and U. We are trying to create an infinite dictionary that contains all possible combinations of these letters. Where do we start? Well, the first word would be D, then DD, then DDD, and after an infinite number of Ds, we would get to DL, DOD, and so on until we go through all the words that start with U. Then we split our dictionary into 4 volumes, each containing the words that start with D, L, R, or U. Here's where things get tricky. Let's take the D volume and write down all of the possible sequences. Then we remove the first letter in every word since we already know what it is. Look at what we are left with. The entire dictionary. Now imagine that these aren't letters but directions. Down, left, right, and up. Here, pick a point. All of the sequences of letters we mentioned earlier are ways of getting to other points on the sphere. Here's D, DL, DD, DR, and all the other sequences. But notice that we can't have LR or UD, since they are two opposite directions that cancel out. We can repeat this with every other point in the sphere. Then, like the dictionary, we'll split the sphere into the 4 direction groups and set aside the reference points. Let's look at the down group. In the dictionary, we just crossed off the first letter of every word, but with a sphere we can't do that. What we can do is rotate it up. This is the same as adding a U to the start of every word, which cancels out the two opposite directions. Just by rotating it, we've turned it into the down, left, and right groups, but we're still missing the up group since we couldn't have down and up in the first place. So we add in the up group, and now we're almost done. If we repeat this process with the left and right groups, we make another sphere. All we need to do now is to add the reference points. There are an infinite number of reference points, and if you can remember, infinity divided in half is infinity. So we split them and voila! We've made 2 spheres. 1 equals 2. This paradox shows us just how perplexing the concept of infinity is, and it reminds us of how powerful our minds really are.